what innovations would we not have today? Containers certainly might not be what they are. There were other competitors. There was Swarm, there was Mesos, but we know Kubernetes kind of won out, and Kubernetes allowed us to solve challenges such as scaling, the management of secrets and configurations, failover, and ultimately at this point, Kubernetes is effectively the container operating system, right? The number of times we have people come by our booth even and ask the question, or we ask them the question, where are you guys deploying into? The majority of the time it was Kubernetes, right? So Kubernetes has really become a new standard, and it's enabled really unparalleled innovation. When you even think about operators, right? Like we wouldn't have operators if it wasn't for Kubernetes, and now we're actually able to sort of codify these industry practices that we have for automation, application deployment, secrets management, all the different things that it does, right? So it's extremely important technology. Our question is, what would be the analog of Kubernetes for software delivery, right? So we have this concept of cook or consume, right? And that means, do we cook the soup or do we just eat the soup, right? Ideally, consuming gets you your results faster, right? If you're hungry, and most organizations are, whether or not you're not-for-profit or whether or not you're actually an organization that's making revenue off of your products, getting your results faster, being able to focus on your product, and being able to deliver value to customers and or users is of the utmost important. Most automation today around software delivery is cooked. It's home-baked. Everybody is using some tool of some sort, and they're building it in-house. And it ends up becoming extremely time-consuming, extremely expensive. And that's not to say that we don't need that expertise. It's actually essential for the organization. But the question is there a way to consume it? I like to use this analogy of, if you are a woodworker and you build tables for a living, and you want to get your tables delivered to customers, you outsource it to a delivery company, right? It'd be kind of silly to go and make your own shipping and logistics organization, right? But in software, we do this over and over and over again. We end up building our own software delivery, and a lot of it just comes down to the unique needs of our businesses, really the immaturity of the practice, the growing automation, the immaturity of our industry as a whole, right? Software development is still pretty new in terms of, or I guess you say when compared to things like building buildings and other things like that, right? So this home-baked thing happens quite often. So our question is, can we build a model that's consumable? And we've sort of built this into our solution, and we will be showing a slight demo of that and how it looks towards the end of this presentation. So you say get off the hamster wheel, right? It's not really reinventing the wheel because there's innovation, right? With every new iteration or new thing, right? It's like operators. They're not really doing anything new, but they're looking at a problem in a new way, right? Offload it into some piece of code that's operating inside of this other piece of software that can do it for you. But it's sort of a hamster wheel. You end up getting into automating your software delivery, and then some new requirement comes or some new technology comes, and quite frankly, we end up getting drowned in these tools. There's just so much tool overload. There's so much to learn, so much to know, and oftentimes we don't really have time to become subject matter experts in the tools that we use. We just scratch the surface, and oftentimes we're overwhelmed, to be honest. So we're trying to find a way. How do we move forward? How do we stop spinning our wheels and actually move forward on the path to innovation and being able to deliver greater value, right? So this slide here is our approach to standardization. We have this idea of holistic standardization, and how we achieve holistic standardization is by focusing on atomic standardization. So as you see on the slide here, we got tools, frameworks, deliverables, and destinations, and we really focus on how do we standardize each one of these small little building blocks, right? So when we talk about tools, these are going to be your CI tools. These are going to be your your sonar cubes. These will be your actual CI tool in and of itself. This would be things like single sign-on, all the pieces that are required just for the software delivery portion of your product. Your frameworks would be your application frameworks. It could also include regulatory and compliance frameworks, but it's predominantly going to be things like React or Spring Boot or any other frameworks that you're using in your respective languages. Deliverables is how you're actually delivering your code. Is it going on an embedded system? Is it going to be mobile in an app store? Are we going in Kubernetes in a container, right? And then your destinations will be where are we actually putting this code once it's done, right? So yeah, we have a container, but the container's got to go somewhere. Is it going in function as a service on Lambda? Are we going in Azure Containers? Are we going on Kubernetes? Are we going like I said on embedded? So by focusing on these small atomic standards, and by standard we mean how does this tool operate within the ecosystem of TruStacks? For instance, if we have a CI tool, we want to wire it into single sign-on. So by default, it has an OpenID Connect client or something along those lines, right? Or for the frameworks, what are the vendor best practices that's prescribed by that framework? If you're using React, are you using Jest, right? Are you using ESLint and the built-in capabilities that React are already built into that framework so that you don't have to rebuild it yourself? Same for deliverables. Are you doing standard things with containers? Are you doing these sort of ad hoc in-house things? By building these standards, we can create one sort of holistic standard, and that helps us achieve this whole standardization process. The advantage of looking at it as small pieces is that we can actually plug and play these little pieces as we go, but we never lose our ability to achieve holistic standardization because it's across the entire solution, right? If I came to any one of you guys and said, I'm going to standardize your whole organization, you'd probably laugh me out of the room, right? Like, no way. But if I say we can start by these little doing these little building blocks, it's a lot easier to achieve. So what I have here is the overview of what we're going to show in our case study / demo. So behind the scenes, really, that's where everything is at right now in terms of visibility. The tool is currently open source. So everything is deployed inside of a Kubernetes cluster. So what you see here is a number of blocks that start at the bottom left at the core components. Core components include Authentic and Concourse. Authentic is providing single sign-on. Concourse is the CI tool of choice, at least in this tool chain that we're deploying here. We have Argo CD as well, which is considered a supplemental component. The difference between the core and the supplemental is that the cores are essential. We can't live without these things inside of our tool chain. They have to be there in order for us to be able to deliver your software. Supplemental components actually come with the workflow. So in this case, this React application is deploying into a Kubernetes environment. We're doing a GitOps-based deployment. We need a GitOps tool. So that actually gets deployed on the fly, and it comes with the workflow. At the top left, you have the React pipeline that runs inside of our workflow runner. Our chosen workflow runner is Dagger. That gives us the ability to be portable across different CI tools. So if you're using Concourse, Jenkins, GitHub Actions, we don't really care. It's all running in our Dagger automation. Our workflow is completely abstracted away from your repository, so you don't have to touch it. It's just pre-built. You point us at your repo, and we bring the code into our workflow runner and execute it. You have these ephemeral components at the top right. Those are basically just containers. That'll be things like open source shift left SAS scans. That could be Trivy database scans. These are all containers that spin up during the pipeline process, execute their desired action, and then they tear themselves down. So they're completely ephemeral. They're not long-lived inside of the tool chain. They don't live in Kubernetes. They just come up and go down. And then on the bottom right, you can see Kubernetes. And Argo CD does the GitOps-based deployment into that Kubernetes environment. So this is the picture of what's happening behind the scenes. Our engine actually manages all the automation of these components. So in order to get here, it's 2 commands and 1 config. It's 1 declarative configuration. We define things like where do we want our network to be? Is it public or private? Are we in the cloud? Are we using Cert Manager so that way we can manage Let's Encrypt or custom PKIs? All that is baked into the engine behind the scenes, and the individual components already know how to operate within this ecosystem. Likewise, like I said, even for Concourse and Argo CD, they actually create their own OpenID Connect clients to connect to the Authentic single sign-on service. So I'm not going to keep talking. I'm going to go ahead and show you guys the demo here. So I'll bring this guy over here. And what we have here is Concourse. So the first thing we need to do is go ahead and sign in. And when I log in, you'll see the SSO option. So now I'm redirected to Authentic. Don't save. And now inside of Concourse, what I've done is I've gone ahead and pre-install the application in the interest of time, so you guys don't have to sit here and watch the factory deploy. When we install the application gets 2 things. It gets secrets and variables. We categorize all inputs as generic inputs, right? Obviously, variables are just open values. They're plain text. Secrets are obviously secret values. We can see examples of that when we click into the demo app. I've already done a couple of runs on here, but I'm going to go ahead and kick off a new one. While I wait on this, let me see, where's my, did I F11 this? Oh, my top bar is up here, so I can't really see it that well. So let me show you this before I kick off the pipeline. So this is actually my source here. This is a clone version of our React tutorial project. It's literally just a create React app. That's all it is. I just run CRA and push it into GitHub. That's it. I do have an ESLint here. This ESLint just says, hey, extended existing React app ESLint rules, so I don't have to make my own ESLint file, and my pipeline is not going to bomb. I have this repository, so it's just an open repository, but I actually am using SSH keys to pull the code. We figure, if people need to use either open key or open repositories or private repositories, just make the standard where everything is considered private, right? So when you use your repository, and you give us the, well, not us, but TruStacks, the tool, you give it the repository and your SSH key, and then we can pull it, right? Over here, we've also got Docker Hub. And in Docker Hub, I've got this React tutorial application. And this is where we're actually going to push our image to. You can see we're currently on tag 040. And you can see these tags correlate with that here. And I've also got Argo CD, wherever it's at. Where are you at, Argo? There's Argo. And now I do my login via SSO. You see I get re-forwarded to Authentic again. So again, all the single sign-on is all handled. And I keep stressing, I know it's like simple, it's like, hey, it's single sign-on, big deal. But it's all done for you. And that's really what we're trying to emphasize with the way this tool chain works. Existing tools out there, they're not necessarily automating all of your tools. They're not providing a workflow that just works right out of the box, right? So now I'm gonna go ahead and click run. This will kick off the new pipeline. You see my secret source and vars down here, they start getting fed into the concourse pipeline. So here's my source, and you can see here it points to my React tutorial. It's got my commit hash. We have our image, which is the workflows container that I was telling you about. So in the diagram, that was that little box that showed the React pipeline going into the workflow runner. Here's all my variables. We have my age public key, my Argo CD server, my get remote, image tag. The ones that we provide will be the project, registry host, registry username, and workflow. The image and image tag are relatively fixed unless you have a new version of the workflow runner for some new features. The age public key and Argo CD server are system provided. So by default, when you spin up a new tool chain, we automatically create an age secret. And that'll be a public and private key. So that way we can handle all the encryption of your secrets as the pipeline is executing. And then the Argo CD server is automatically generated. When we spun the Argo CD server up via the tool chain, it has rules that says create me a service account, because it expects that the pipeline is going to be leveraging it. So it automatically creates a service account and an anonymous password for you. Not anonymous, but I guess I'd say generated password. So you don't have to manage the password. It's all done. And then down here we got our secrets, and you can see they're obfuscated. But that's just the password for Argo, get private key and registry. So if we go and we start looking at the run, we first start with the setup step. In setup, we pull in the code, fetch all tags, identify which tag we're currently on, which you can see is 040, and we already saw that in the repository. The key piece right here is this little guy right here. In this commit, you can see this FEAT prefix for feature. Are any of you familiar with conventional commits? All right, so you know how they work. For everyone else that doesn't know how they work, conventional commits are a way of generating automatic semantic versions. So if you put feature, it knows it's a minor. If you put fix, it knows it's a patch. And if you put feature bang or fix bang, then it knows that it's a major upgrade. So you don't have to worry about the versions. All you have to do is just put it in your commit and you're off to the races. You can see down here, it recognizes 050 is the next version because it was a feature prefix. Now we move into build. It's a React application, so there's no build, right? Not yet, at least, because this would be a pre-build in order for you to run tests or other things. So if you have a compiled language, this step would be significant. And that's one thing is we have a prescribed way of doing the pipeline, right? So we do setup, we do build, we do test, we do package, we do publish, we do stage, and then there's production. By isolating these steps, it actually allows us to keep resources because this pipeline actually runs as one giant step. It's all handled inside of the runner because it's all isolated into the Dagger process. So we do it as a way to manage memory and make sure everything gets freed up between all these container builds. And all these sub-steps are done behind the scenes in BuildKit. So caching is automatic and everything runs in a container. Even if it's something that's talking to one of the services in the tool chain, it's still running inside of a container. So now we go to our test step. You can see we start building a bunch of containers. And here's the actual container builds here. So you can see like installing libcurl. This all looks like Debian-based stuff, right? Installing React scripts. Down here's our unit test step. It's a small test suite because again, it's just a sort of a pet project type deal. But we got one pass, one total. So the framework already knew that we were using Jest because we use create React app. and this workflow says, I know how to run a create React app-based project. And the best practice is to use jest. So if you use jest the way you should have, then it'll just work, all right? And here in this step, you can see this command. We actually enrich this. We enrich it because we really don't trust that no one will touch that script. So what we do is you say, we know this is the command that we want to run. We know we're running React scripts test, and it's also a security thing to make sure that if you have any like zero trust with this pipeline, that no one is messing around with it in the source code to try to manipulate things, right? But this also gives us predictability. The goal is to create these pipelines to be as deterministic as possible, so that way we can reduce the chance for failures. So we'd rather enrich it than take the chance on this command being changed or fat-fingered by somebody messing around in the package JSON and actually saving it. So now our test step is done. There's also lint. It's pretty boring because there's nothing coming out of it. So it's basically like log on error or do nothing. So you can see that lint's computing. Down here, lint completes. Now we move on to our package step. In our package step, we containerize the application. We run a static application security test with shift left. So we'll check for CVEs, we'll check for dependency issues, and we'll also check for credentials that are in the repository. So if you accidentally forget to delete that private key you were testing with, it'll throw the error. We also run a Trivy database, a Trivy container scan against the container to make sure there's no vulnerabilities in the container operating system. So we get down here. There's a scan going now. And this can take a little while, so if it gets hung up too long, I'll jump back to one of the old builds while we wait for it to finish. But you see right under the big, unmissable, I guess that's a word, scan text, where it says using plugins, Node.js, TS, cred scan, dep scan. That's all built into the workflow, so the workflow knows exactly what to look for. Now you can see now the Trivy scan is starting here. So it's downloading the security database. And you'll see it right under that text in a second. It's going to pop up, and it's going to say that it recognized the Red Hat operating system. By default, if at all possible, we try to standardize on Red Hat UBI 8-based images, just because they're relatively secure, right, compared to even like Alpine or something along those lines. If there is a better container, right, like the official Docker Python containers are pretty powerful. It's kind of like, why start with UB8 and rebuild the entire thing unless there's a very, very strong security need? So we can also support those images. This image itself is effectively just an Nginx container that we put some health checks on and just expose the static React application. So since we built it and it's so simple, it's using UBI 8. You can see on the about 6th line up from the top here, this is where we did the push of the image. So now we should have tag 050 in our Docker Hub. Refresh. All right, there's 050 as of a minute ago. And let me use the other click. And sometimes this step, the last bit of the scan can just take a second. So I'll give it another few seconds, and then if that doesn't work, I'll jump over. I've also ran it a few times in the network. It seems like it just sort of stopped, and then I refresh the page and everything is green. So let me see in Argo if it's actually retried. Yeah, it's still on 040. I'm going to pull this over here to the side if I can. Let me see if I can do this, because I'd rather be able to see that happen at the same time. This might get a little bit too small. Oh, man. Don't close. Okay. Let me do a quick refresh just to see if this is hung or not. Yep, see, it actually made it past it. So now we're at the publish step. During the publish step, this is where we build all of the Helm assets. So the Helm assets are built into the workflow. So we'll have a deployment, we'll have a service, and a number of other pieces in the Helm charts. We actually run the Helm chart through Customize. So we use Helm to pre-template, and then we use Customize to actually deploy. The reason why we use Customize is because Customize supports a tool called KSOPs. And we use SOPs in order to encrypt the secrets and push them into version control. KSOPs doesn't work with Helm. So it's a lot easier to just say, well, it's nice to have Helm templates. So we use the Helm template command just to generate all of our templates based on inputs, feed them into Customize, and push them into Argo. That age public key that you all saw at the beginning in the inputs, Argo holds the private key. It doesn't hold it exclusively. It just knows that it's there. So when we spin it up, it gets fed in because the engine understands it needs to send that secret in. So now Argo has the ability to decrypt any secrets that were created in your pipeline automatically. You don't have to worry about it. And the advantage there, you could use Vault. There's other ways of doing the secrets, right? But the advantage is that it's all in version control. So the holder of the key can decrypt it. But if you needed for any reason to go back and audit and figure out what that secret was at some point in time, you can do that. It's a little harder to do that with something like Vault. So now you can see the sync on the right side. And it's very simple, right? The application was already deployed from a prior tag. But that's the pipeline end to end. So now here's the Argo output. I'm definitely going to close something. Let me see if I can do this. Yeah, here's the output from Argo and the sync status. So that's the full pipeline end to end. So if we look at what we have now in the repository, if I can get to that. So in the repo, oops, not that. I do a refresh. And now I have tag 050 in here. If I click 050, I have this customized directory. And here's my customization base file, or base directory. And here's that registry secret I was telling you about. So you can see here, it got encrypted with SOPs as the pipeline was executing. But you saw the pod deployed in Argo. So it actually does have the ability to decrypt it all. So this is what your secrets will look like in the repo. They're never exposed. So, and last few pieces on the slide. Let me see if I can get back to it here. Where did my slide go? Here. So Nextops, after the demo, and we can do questions or anything if you guys have some more about it towards the end here. But with respect to Nextops, the reason why we labeled this talk Nextops is because we look at things, like I said, operators, things that we've done with Kubernetes where we've been able to innovate in ways that we could not have imagined being able to do them if it wasn't for Kubernetes, right? That's why we asked, what's the analog of that for software delivery? What happens when we have a solution that's so solid and so robust that we've taken all of our collective knowledge, we put it into this tool, what's next, right? What comes next? There's a lot of technologies that are already out there. Like, are any of you guys doing chaos engineering or threat modeling? Right? There's multi-year-old technologies and ideas that have just not been able to be tapped into because, quite frankly, we're all on this wheel, just repeating and rinsing and repeating, right? So that's the question is, how do we get past stifling innovation? If we're continuing to do the same old things across the industry, how do we bring all that collective knowledge into a single platform? And for organizations that can just standardize and just say, hey, I'll just use React out of the box. I'll use Angular out of the box. I'll use Spring Boot out of the box. And I'm going to stick close to that spec. We're basically able to allow people to move on to these next things and, bring more innovation and make their products better. So last slide here is better together. We have a Discord channel. We've just gone open source recently in the last couple of months. We decided to take this tool open source. So we're looking for any open source contributions, open source suggestions, right? If you guys love it, you hate it, you have a suggestion, a framework you want added, a feature you want added, a component you want added. We're looking for anything and everything that we can get. Our feature goal is to have committees around these different frameworks. So whichever frameworks, if you're programmers, whichever frameworks you're using, we really want contributions, if not literal code contributions, at least ideas about this is how you should or shouldn't be doing that, right? There's infinite knowledge that exists in this industry about how to do this perfectly, right? And we believe the problem's solved. There's no reason for anyone to continue to redo it over and over and over again. And, DevOps is massive. Like, software delivery is a piece of it, but, I've done, a number of, troubleshooting sessions on, issues with applications where we're digging into logs and we're digging into, monitoring tools and everything else. Like, that's human effort. Those are things that are so difficult to get a machine to understand because those processes are so business specific, right? I mean, we talk AI, maybe we eventually get there, but, those are problems that are better served, having human minds on, right? Versus us sort of repeating the same old processes over and over, right? Let's solve it once and for all. So I think that's the last, slide, sorry. Yeah. And that's the end of the presentation. Any questions? Very cool. Did you guys like it? Did you guys learn anything, or you guys like, I mean, what do you think of the solution? Any comments, feedback? I'll call on you. Was it cool? Okay, cool. Or was it terrible? Cool. All right, Gary, did you have anything you wanted to add? Yeah. It's like regulated industry stuff. Yeah. Do any of you write pipelines? Do you enjoy it? Yeah. I mean, yeah. Yeah. Not this one. This one's running in our cloud instance, but I do. It's easy to run. TruStacks.com, and we have our actually docs.trustacks.io will take you to our docs, but I think we have the link to it on our website too. And you can run the entire thing in K3D, and the exact React application I just ran, it's actually in our main repository, so you just fork it and execute it. We got Fast API coming and a couple of other frameworks. The majority of the work we've been doing is just getting the engine settled because it's just so many moving pieces. But yeah. Yeah, originally it was Concourse because Concourse was one of the only tools that could actually pull Git other than Jenkins. Most of them required webhooks, and I'm like, well, if we want to run it on a laptop, it's kind of tough. Over time, I basically got to the point where I'm like, well, it's just a demo. You can just press the play button and make, just for this sake. But we really wanted to be able to show the whole kickoff process, right? Most people aren't just sitting there like, hey, did you commit the code? I'll push the button, right? It's all automated. It's kind of silly to automate the last, 95%, and you got to kick it off manually. So, But yeah, I mean, it uses concourse, but that's the beauty of it, right? Is that it doesn't really matter what your CI tool is. And even that Dagger tool that we're leveraging on, like that's what we're trying to do. We're trying to isolate CI away from all the tools. Have you ever done a migration of pipelines from one tool to the other? Yeah, it's a bear. We started everything on, we have some of our stuff in GitLab. We started transition to GitHub because lots of open source projects are on there. So just moving existing pipelines from one system to the other, I'm like, man, if we would have just had this, like, I mean, first off, we wouldn't even have to move the pipeline because our our pipelines don't live in GitHub Actions or GitLab or anything. But second, we could have just said, okay, we'll go and create a GitHub Actions runner, and then just put that inside of our tool chain, and then we just run the same pipeline we've always run, and then there's no change. And the goal is to make these super robust, right? Like most people have gaps in their pipelines. They have some things done, but I mean we showed here unit test, lint, semantic versioning. We showed static application security test, database testing. I mean no, not database. Yeah, I keep saying database because it says TriviDB and it's so in my brain. The Trivi vulnerability scan, containerizing the application, secrets management, staging the application in Argo, but there's still more. There's UAT, there's API contract testing, there's integration testing, there's bill of materials, and then if you're regulated, it's even more, right? So over time, these pipelines are going to become so sophisticated, right? Now the downside to that is sophistication and complexity increases time, but that's where the caching comes into play, right? And if you don't need that, complex of a pipeline, then it's like, well, just disable these certain steps. But I would rather have steps that I could just enable on a click of a button than have to go build them myself, right? So that, and the thing is, most of these are common. Like the steps, other than the lint and unit test step, they were not specific to a given language. They could have been used for every single language. So that's one of the advantages. Actually bringing on new pipelines as more and more features get built takes less and less time. And once these components get to the point where they're day 2 ready, so they're automatically doing backups and things like that. Is anybody on the infrastructure side? I know you're doing pipelines, but do you guys you guys are developers? I'm assuming. So how often do you upgrade all the dependencies in your packages? Like you have your app, are you front end, back end? Oh, okay. Well, what are you writing it? Okay, what programming languages? Yeah. C++? Okay. Are you back end? What language? Go. So if you had to completely update all your Go vendor packages today, would your project break? Do you think it would break, or would it just work? If you had to basically get rid of your entire Go vendor package and you got the newest version of every single package in your projects, do you think your code would break or not? Yeah, and that's most organizations, the code would break, right? So there's implications to keeping versions pinned because, if you run the code and the CVE comes up, all of a sudden it's like, whoa, like Neo4j a little while ago. That was a big deal, right? I mean, all kinds of applications just immediately broke. No one touched anything. Everybody was vendor locked. Everybody's code was stable. And then all of a sudden this Neo4j, 0 day comes out and everyone's freaking out. How hard was it for some organizations to actually move forward, right? They had to take significant time shifting all their focus over to that. So that's Nextops, right? Nextops is tools like Renovate, where it would literally take all of your dependencies, upgrade them all in a separate branch, and let's see what breaks. But if we weren't doing things like spin our wheels in CI/CD, could we spend our time keeping our dependencies up to date, being able to keep cutting edge? Like what happens when we can adopt that type of practice is maybe legacy applications won't be a thing anymore, right? I mean, the only today's applications are tomorrow's legacy applications, right? I mean, it's just the nature of the beast. And it happens because we version pin, because it takes years to be able to just get to the point to where we can upgrade everything. And the larger the systems get, the greater level of dependencies, right? And it's not just because of security, right? I mean, like you said, if you update things might break because you have major versions, right? The APIs are totally different. It's a better way of spending our time, is keeping our products up to date as opposed to shifting our focus to all these other, additional tasks. And specifically software delivery, like I said, there's certain parts of it that you just can't do that with. But this problem is mostly solved. It really is. So, C++, what are you guys going to school for? Engineering. Are you just general engineering, or is it like, okay. What else other than C++? Java, Python. Okay. Are you guys playing with like Python package managers, like pip or any of that stuff? Yeah. Like, do you have any long living projects? Like little things that you built, or like larger projects? Okay. Okay. Yeah, because I mean, it's a question I like to ask people, like, what would happen if you just upgrade your dependencies? But if you don't have a longer project, it's harder to know, Everything breaks, yeah. Yeah, and that's the thing, like, we always think in terms of versions and software at a point in time, but it's like, software should be moving forward, right? I mean, it's trying to keep it from getting too old, so. Yeah. I won't ramble about it anymore. It's just a cool question to ask. Say it again. Yeah. Yeah. Yeah, everything is different. Yeah, and it's, transitioning platforms, I mean, I definitely think that's sort of obvious, right? Um, we've seen it a lot, right? Somebody builds an app and they go, oh, it's done. It's like, is it though? Because if you don't maintain it, like I had a project where there was an application that gets built one time a year. So the security team was all on it because they're like, we have to make sure that you guys are constantly upgrading things, right? They say, well, we only build one time a year. So if you update everything once a month or every 3 months, we're going to be in a situation where, our code's not going to work. It's kind of like, but you have to keep maintaining it, right? You can't just let it sit. Otherwise, it'll be outdated. And you could have some serious dragons in that code in a year, especially if it's a Java application with Neo4j in it, and you let it sit for a year. Man, that's scary, right? So, and for old versions of Neo4j, I'm not trying to rag on it too much. It's just the most recent example that most people know about, right? So, and like I said, that just fits right into the model of Nextops. Most people aren't even thinking about that today. Like, how do I just upgrade my code? Most people aren't thinking about like how do we do better with things like configuration, right? So, yeah, there's a lot of really cool and innovative ideas that are coming out though. So we're excited to be able to facilitate it and add more and more into the pipeline as we go. That Renovate tool is something we're looking into. So you can basically say, hey, we're going to do a migration, and you just spin it up. Maybe like every month it just says, hey, here's all your stuff that's out of date. You need to come over here and fix this. But that's the reality, right? If you just dedicate time to do it, and that's tough, right? It's very tough, especially, I mean, if you guys are in school still, I don't know if you guys are working on any major projects. When you get, when you're working for dollars, it gets really hard to go to your management and say, hey, we need a week to fix all these upgrades, right? They'll look at you like you're crazy, Most of the time, we don't have enough time just to build the stuff that we're assigned to build. So, let alone being able to go back and do those things. But it's just, it's really driving in the value, right? And it's a lot easier to say, hey, if we don't do this other thing, then we can get to doing this thing. Because the most important thing you're building is your product. That's just, there's really no way around that. Nothing that you build is more important than your product.